Good day and welcome to this lecture. In this lecture, I will show you how to model pressure safety valves using Aspen Hysys. Now, pressure safety valves are safety equipment that are either attached to pipelines or process equipment in order to protect them from overpressure scenarios. Now, they usually operate based on a set point such that once the operating pressure of the equipment exceeds this value, the valve opens rapidly. Now, they are usually designed to operate without any human intervention. What that means is that the valve opens and closes by itself, right? So basically, that's how they work, right? And this is what pressure safety valves are all about, right? So we have different types of pressure safety valves. We have the conventional safety relief valves, we have the balanced bellow safety relief valves, we have the pilot operated safety relief valves, we have the power actuated safety relief valves, we have the temperature actuated safety relief valves, we have the pressure vacuum safety relief valves, and then a couple of others, right? So if you want to get detailed understanding about how these different pressure safety valves work, you can actually do some research about that. So moving on, we have a sketch of a pressure safety valve on the screen. We have a sketch of that. So this is a diagram of a pressure safety valve. So you have the set pressure adjusting screw, then you have the spring, you have the bonnet, you have the body, you have the disc holder, you have the set discs, and then you also have your inlet, right? So this is the inlet to the pressure safety valve, and then you have the outlet which is also the orifice, right? So the orifice, so this is where the fluid is supposed to come in from. That is the nozzle, and then it's supposed to go out from this other side, right? So this is just an illustration of a pressure safety valve, right? So how it works is that you have a set pressure, right? You have a set pressure that the safety valve operates based on. Now, when the fluid passing through the equipment or the pipe exceeds that set pressure, the force of that particular fluid will push the discs, right? This set discs is going to push it up, and this also automatically pushes the spring, right? It pushes the spring up, and then the valve opens, and then the fluid can come out from the outlet, right? The outlet of the valve, right? So this helps to actually keep equipment and pipes safe, right? So basically that's how these pressure safety valves work, right? So for pressure safety valve or pressure safety valves, we have certain very important parameters that I will be explaining in this part of the lecture. So you have the operating pressure. Now the operating pressure is the pressure at which a particular equipment is designed to function, yes, while it is in safe use, right? Then you have the operating temperature, which is the temperature at which an equipment is designed to function while it is in safe use. Then you have the design pressure, which is the maximum pressure that can be attained by an equipment while it is in safe use, right? So that is your design pressure. Then you have your design temperature, which is the temperature, the maximum temperature that can be attained by the equipment while it's in safe use. Then you have the set point or set pressure, right? So this is the specific pressure a PSV, a pressure safety valve, is calibrated to. such that it is expected to open rapidly in order to relieve an equipment of excess pressure, right? Then you have your relief temperature, which is the temperature at which the PSV is set to open in order to relieve the equipment of excess temperature. Then you have your relief flow, right? So relief flow has to do with the flow rate of the fluid, and this is the flow rate at which the PSV is set to open in order to relieve the equipment of excess fluid, right? Then you have your back pressure. Now, back pressure is the pressure that tends to act in the opposite direction of fluid flow, right? That's what back pressure is. Then you have your scenario, right? So when designing pressure safety valves, you have to design them based on a particular scenario, right? So scenarios are basically conditions in which a safety valve is expected to take action, right? So, and we have a couple of them, which include the blocked outlet scenario, overpressure, thermal expansion, fire case, etc., right? So there are a couple of others as well, right? So you have scenarios, right? So basically these are a few of the very important parameters that are associated with pressure safety valves. Then for pressure safety valves and pressure safety valve design, you have certain standards that are used to actually design them, right? So you have the API 520, API 521, and API 526, right? So these are the standards that pressure safety valves are designed based on, right? They are industry standards. Now, the API 520 is a general standard that is used in the design of pressure safety valves, while the 521 and 526 are specific to the oil and gas industry, right? So for API 520, it includes the methods required for the installation of pressure relieving devices for equipment that possess a maximum allowable working pressure of 15 psig and above, while the 521 is required in the analysis of overpressure scenarios and in the design, sizing, and installation of pressure relief systems. API 526, on the other hand, is used in the design of pressure relief and pressure safety valves, right? It is used mainly for the determination of the specifications and material of construction of a particular valve based on the desired scenario, right? So for 526, we have this particular table right here. So this table is for, or it's from, right? It's from API 526. So this table is actually used to select a particular orifice size for the pressure safety valve, right? So this is actually the table that is used to select a particular orifice size, right? So with this, we can get into the software environment so that we can begin to actually simulate and model pressure safety valves, right? So we'll be taking an example where we actually model a particular scenario, right? So these are the data required for the model we'll be illustrating in this tutorial, right? So let's get into the simulation environment. So first off, we are going to select our components. So we are selecting components. We have water. So we are modeling steam in this particular illustration, right? So we have water, then we have methane, yes, then we have oxygen and nitrogen as the components of air. Then our fluid package is our fluid package is Pen Robinson. So we can select Pen Robinson and then we can get into the simulation environment, right? So with that, we can get into the simulation environment. So in the simulation environment, we are going to be specifying a valve first. So the valve, in the valve, we are going to specify the feed to the process, which is water, right? So water is the feed to this particular process. So we have a pressure drop of 10 kilopascal. Then we have the properties of the water stream in our document. So we have mass flow, we have pressure and temperature, which are atmospheric conditions. Then the mass flow is 500 kg per hour, so we can specify all of that. So we have we can start with the composition. For composition of water is 1. Then the conditions, you have atmospheric conditions, we have 1. So we have 1 atm, and then we have the mass flow as well, right? The mass flow of water. Yes, so this is the mass flow of water. Now this is fed into a centrifugal pump. So we can model a centrifugal pump. Just change the icon. Then we can specify the outlet. We can attach an energy stream, and then we also attach the inlet, which is the outlet of the valve. So we have the outlet pressure of the pump. Pump outlet pressure is 7.3 bar G. So we can specify that 7.3 bar G. Yes, so the pump is fully specified. The pump is fully specified, so we can continue with our model now. So this water from the centrifugal pump is then fed into a fired heater that converts the water to steam. So basically that's what we are doing here in this simulation environment. So for this we have our inlet and outlet streams. So inlet is the outlet of the pump, then our outlet is steam. We have steam as the outlet. Then it says requires an air feed, so we are going to create an air stream. Sorry, let me just confirm. Okay, so I have only one stream. So we created an air stream. Then we are also going to create a fuel stream as well. Yes, then also we need a stream for the combustion product. So the combustion product is usually consists of CO2. Yes, CO2, then CO, and the likes. So we can specify some of the streams we have created. So let's start from the air stream. So we have details for the air stream in our document. So for air stream, we have the fractions of oxygen and nitrogen, then we have the conditions as well. So we can specify those. We have 25, then we have 1, we have 1 atm. Then composition, we are making use of liquid volume fraction because air is specified in terms of volume. So we have 0.21 and 0.79 nitrogen, 0.21 oxygen. Then this is all right. Then we are also going to specify our fuel. In this case, we are making use of methane as the fuel for this fired heater. So methane is the fuel. Then let's go back. So for methane we have 25 degrees Celsius and 1 atm, so we can specify those as well, right? Sorry about that. So we have 25 degrees Celsius and then 1 atm, also 1 atm, right? So this is all right. So after specifying the fuel and air streams, the next is to specify the efficiency of the fired heater, and the excess air percent. So to do that, you just go to your design tab and you click on parameters, right? So under parameters, you can actually specify both parameters. So you have efficiency of 85% and then 5% excess air, right? So after this, you can then specify the outlet temperature of the steam, right? So, and this value is at 203.5, which is steam temperature 203.5 degrees Celsius. So 203.5 degrees, right? So after doing this, your model should solve, right? So your model should solve, and at this point we can now start our PSV sizing. Yes, so we can now start our PSV, our pressure safety valve sizing, right? Now, to model your pressure safety valve, the first thing you have to do is to ensure that your model is fully specified and it has solved without errors, right? So your model has to solve without errors before you start attaching pressure safety valves. So to attach pressure safety valve, you need to make use of the safety analysis environment by your bottom left, right? So if you can see my cursor, by your bottom left you have properties, which is the simulation basis manager. You have the simulation environment, you have safety analysis, and then you have energy analysis, right? So you have to make use of the safety analysis by clicking on it. Yes, so once you click on it, the safety environment appears, right? So this is the safety environment. Yes, so in this safety environment, you have the add PSV, you have add rupture discs, you have storage tank protection, and then you have data sheets. But in this case, we are trying to model a pressure safety valve, so we'll be making use of add PSV, right? So to add a pressure safety valve to our model, all we have to do is to click on it and then place it on whatever stream or equipment we want to attach it to, right? So once you place it there, the pressure safety valve is added to your process. Now you can double click on it and then start your specifications, right? So we have a couple of specifications here, starting with operating temperature. So for most of these specifications, you can either use a reference value or input a value manually, right? Any desired value of your choice can be inputted manually, or you use the reference value, which is the value obtained from the model that was simulated in the simulation environment. So in this case, we specified 203.5 as the outlet temperature of steam, and that has been adopted as the operating temperature, right? So for design temperature, we have our value as 220 degrees Celsius, so we can specify that. So we have 220 degrees Celsius. Now if you want to change to a reference value, you can click on reference, but that's not the case for design temperature. Then we have operating temperature, which is also a reference value, is at 7.3 bar G. Then for design pressure, we have 12 bar G for design pressure. For design pressure, 12 bar G. So we specify 12 bar G as design pressure. Then it says create an emergency scenario. So for emergency scenarios, we have, you click on scenarios, then you click on create scenario, right? You click on create scenario, then you can activate your sizing case and then select your desired scenario from the scenario type. So for scenarios, we have, our scenario is overfilling, so that's why I selected overfilling. Then it says a reference stream must be selected in order to calculate the relief properties. So to do that, you just need to double click on this stream column. You just double click on it, and then it gets you into this environment, and you can continue your specifications. For relieving temperature, we have relieving temperature is 210 degrees Celsius. 210 degrees Celsius. Then we can specify our set pressure, right? We specify our set pressure next. So for set pressure, we go back to the PSV environment and we specify our set pressure. We can specify that under PRD data, right? Under PRD data, we have set pressure, so we can uncheck the design pressure and then specify manually. So our set pressure is 11 bar G. From our data, we have set pressure of 11 bar G. Now also from here, you have your design codes, right? So you have a couple of design codes here. You can actually research about them. Then also you can specify your discharge, right? Where the fluid is going to be discharged to, right? Or discharge destination, right? So in this case, I will be selecting atmosphere, right? Because we are dealing with steam, right? Because we are dealing with steam. Maybe for combustible materials, you may want to discharge to flare, but in this case, we are dealing with steam, so I'll specify atmosphere, right? So after this, we can now specify our reference stream, right? So we can specify our reference stream. Our reference stream is steam, right? So we click on select to specify the reference stream, and then we click on the stream and we click OK, right? So after that, it says relieving flow must be specified. So I decide to specify relieving flow. So we click on reference, because our relieving flow is about 500 kg per hour. So we can make use of the reference value of water. So we just click on it, and once you click on it, your design is specified to an extent, right? So the next thing to do now is to select a particular orifice size, right, select a particular orifice size. So for orifice size selection, you must select a value that is higher than the calculated orifice size, right? So your selected orifice must be greater than your calculated orifice, right? Slightly higher than your calculated orifice. In this case, our calculated orifice is 0.76, so our selected orifice should be from 1.264, right? So I'll just select 1.264 for this particular model, right? So we cannot select 0.709 because it is less than 0.76, right? And from here you can also see that these values are actually similar to the values we have in our documents, right? So we have these values for orifice size selection, as you can see, but the values are in millimeter square, while the values in Aspen are in centimeter square. So it's just a matter of conversion, right? So for example, we have 1.264 for letter E, right? So if you check letter E here, you have 126, right? So 126 millimeter square. So you can see that the values are actually similar. You have 71 millimeter, which is about 70.9 millimeter squared, which is 0.709, right? Which is what we have here for letter D, right? If you check letter D, yeah, letter D is 0.709, which is similar to what we have in that particular table, right? So at this point we have done most of the design of this particular pressure safety valve, right? Pressure safety valve. So after this, what we have next is to specify the nominal diameter of the inline and outline of the PSV. So that is what we have, and this is required to calculate the pressure drop of the inlet and outlet, right? So to do that, you click on line sizing, right? You click on line sizing, and then you can specify the inline and outline nominal diameters respectively, right? So now for that, you can use your drop down, right? So normally you should specify a value that is slightly higher than the flange size, right? So the flange size is 1 in this case for inline. So you specify values that are slightly higher than the flange size for both inline and outline, right? So for example, I can say 1.5 and then let's say 2.5, right? 2.5. So after specifying both the inline and outline nominal diameter, you click on run line sizing, right? So after clicking on run line sizing, you check your status bar to see if the calculations are all right. So in this case, it says for the inlet pressure drop, there is an error for the inlet pressure drop. It says maximum pressure drop exceeded, right? So once you get an error for a particular pressure drop, you are expected to change the nominal diameter for that particular particular input, right? So in this case, you are still expected to choose a value higher, right? Higher than the flange size value, right? So from our document, I selected 2 values specifically. So we have the inline is 2.5 and the outline is 3. So we can just make use of those values instead, right? So we have 2.5 and 3, right? 2.5 and 3. So this 2.5 and 3. So after doing that, we can run the line sizing again, right? So once we run the line sizing, we have our inlets and outlets okay, right? And we have the pressure drops for inline and outline calculated, right? So we have the calculated values for the pressure drop, right? So at this point you have actually come to the end of your design, right, for that particular PSV, right? For that particular pressure safety valve, all the necessary parameters have been calculated, right? So you can actually check your tables, right, from the different sections of the environment, right? So you see all the values have been calculated. Now, one very important thing you must note is that before you specify your stream, before you select your stream, make sure you have specified your set pressure, right? So always make sure to specify your set pressure value before you select your stream, right? So this is to avoid errors in your PSV model, right? So if you select your stream before changing your set pressure value, right, because the default set pressure value is usually the design pressure, right? The design pressure is the default set pressure value, but normally the set pressure value is supposed to be slightly less than your design pressure. Now make sure to change your set pressure value to a desired value before selecting your stream, right, to avoid errors in your PSV modeling, right? So with this, we have come to the end of this particular tutorial, right? We have come to the end of this particular tutorial. If you have questions or observations, kindly let me know using the comment section. Then you can like this video, share with your friends, and then also subscribe to this channel if you have not done so yet, in order for you to get notifications on subsequent videos and tutorials about process modeling. Thank you for joining me in this particular tutorial. Do have a good day.